The metal screams. Sparks fly in every direction as massive hydraulic presses slam down with enough force to bend steel plates like paper. It's June 1942, and inside a converted automobile factory in Detroit, something impossible is happening. A Sherman tank, all 30 tons of it, rolls off the production line. 90 minutes later, another one follows. Then another, then another. The Germans are building maybe 20 tanks a week, carefully handcrafting each one. Here, in this single factory, they're pumping out a Sherman every hour and a half. The engineer said it couldn't be done. The military brass said it was insanity. Henry Ford's people looked at the blueprints and laughed. But Chrysler took one look at the problem and saw something nobody else did. They saw an assembly line waiting to happen, and they were about to turn the entire tide of the war. This isn't just a story about building tanks. It's about the moment American industry realized it could fight wars with factories instead of just soldiers. It's about the engineers who threw out every rule in the book and rewrote them on the factory floor. And it's about how a car company that had never built a military vehicle in its life figured out how to mass-produce the weapon that would crush the Third Reich. Because before Detroit started churning out Shermans like clockwork, the Allies were losing badly. The German panzer divisions were rolling across Europe with machines that took weeks to build. Machines so complex they required master craftsmen and specialized parts. Quality over quantity. That was the German way. And for a while, it was working. But the Americans were about to prove that quantity has a quality all its own. Let's rewind to 1940. France has fallen. Britain is hanging on by its fingernails. And America, still neutral, is watching the newsreels with growing horror. The US Army has about 300 tanks. Most of them are relics from World War I. Light tanks with armor so thin you could punch through it with a heavy machine gun. The newest American tank design, the M3 Lee, is a mess. It's tall, awkward, with a gun mounted in a sponson on the side, because nobody could figure out how to put it in a rotating turret. British tank crews who get stuck with the M3 call it a mobile coffin. They're not wrong. The US War Department knows this. They're desperate. They need a medium tank, something with a 75mm gun in a fully rotating turret, something with armor thick enough to stop German anti-tank rounds. Something that can go toe-to-toe with a Panzer III or Panzer IV and actually win. And they need it yesterday. In early 1941, they give the contract to the Ordnance Department's design team. The specifications are brutal. The tank has to weigh less than 30 tons, so it can fit on existing cargo ships and landing craft. It has to be fast enough to keep up with infantry, and reliable enough to run for days without breaking down. It has to be cheap enough to build in massive numbers. And they want the first prototypes in 6 months. 6 months. The Germans took years to develop the Panzer IV, and that was with an entire nation's industrial base and all the time in the world. The Americans are essentially asking for a miracle, but the design team, led by engineers at the Aberdeen Proving Ground, gets to work. They start with what works: the chassis and suspension system from the M3 Lee. It's proven, reliable, and already in production. They ditched the awkward sponsor-mounted gun and designed a new turret. A big one, with a 75mm gun that can traverse a full 360 degrees. They add sloped armor on the front, not as extreme as Soviet T-34 slopes, but enough to deflect some shots. They keep the engine simple, using a modified aircraft radial engine that's already being mass-produced for bombers. The Chrysler A57 multibank engine, a beast of a power plant made by literally welding 5 automobile engines together into one unit. It's weird, it's unconventional, but it works. By February 1942, they have a working prototype, the T6 medium tank. It's not perfect. The armor is decent, but not great. The 75mm gun is good, but not as powerful as the German 88mm. The thing guzzles fuel like a drunk at an open bar, but it works. It moves. It shoots. It doesn't catch fire when you sneeze on it. The army tests it, puts it through its paces, and gives it the green light. They rename it the M for Sherman, after Civil War General William Tecumseh Sherman, the man who burned his way through Georgia. Fitting, because this tank is about to burn its way through Europe. Now comes the hard part: building them. The army wants 10,000 Shermans. 10,000 in the first year alone, and then they want to keep building them, month after month, until the war ends. Nobody in America has ever built that many tanks. Nobody in the world has. The Germans are producing maybe 200 Panzers a month, and that's stretching their industry to the breaking point. The Soviets are cranking out T-34s in insane numbers, but they're doing it by throwing slave labor at the problem and cutting corners on quality. Half those T-34s break down before they even reach the front. The Americans want quality and quantity. They want perfection at speed, and they want it now. The Ordnance Department starts handing out contracts. Chrysler gets one. So does Fisher Body, a General Motors subsidiary. So does Ford. So does Pacific Car and Foundry, a company that normally makes railroad equipment. So does Lima Locomotive Works, which, as the name suggests, builds trains. By the end of the war, 11 different companies will be building Shermans. But the story really starts at Chrysler, at a factory called the Detroit Tank Arsenal. Chrysler didn't have a tank factory. They had car factories, lots of them. And in 1940, the government came to them with a proposal. We need you to build tanks. Lots of tanks. We'll give you the land. You build the factory. Chrysler said yes. They always said yes. This was the company that had gone from near bankruptcy during the Depression to being one of the big three automakers by sheer grit and innovation. If anyone could figure out how to mass-produce tanks, it was them. They broke ground on the Detroit Tank Arsenal in September 1940. The building went up fast. A massive structure covering over 1.5 million square feet, big enough to fit 28 football fields inside. Open floor plan, with overhead cranes running the length of the building so they could move heavy components anywhere they needed. They designed the factory specifically for assembly line production, something that had never been done with tanks before. Tanks were built in workshops by teams of skilled workers who assembled them piece by piece. Chrysler was going to build them like cars, but there was a problem. Nobody knew how to do that. A car has maybe 15,000 parts. A Sherman tank has over 50,000. A car weighs a couple of tons. A Sherman weighs 30. You can't just slap a tank together on a moving conveyor belt, like a Model T. The thing would collapse under its own weight. The engineers at Chrysler had to completely rethink how tanks were built. They started by breaking the Sherman down into the hull, the turret, the engine, the transmission, the suspension. Each sub-assembly would be built on its own line, by specialized teams. And then everything would come together at the final assembly point. It sounds simple. It's not. The hull alone is made up of hundreds of steel plates, welded and riveted together. The turret has to rotate smoothly on a massive ball-bearing ring, while supporting a gun that weighs over a ton. The engine compartment has to house that insane 5-engine-in-one Chrysler multibank, along with fuel tanks, radiators, and cooling systems, all crammed into a space barely big enough for a person to crawl through. And then there's the armor. Sherman armor is rolled homogeneous steel, thick plates that have to be cut, shaped in heat. Early Shermans used cast armor for the hull front, which is poured molten into molds, and then machined to fit. Later models switched to welded armor, which is faster to produce, but requires skilled welders who can make joints strong enough to hold up under fire. Chrysler had to train thousands of welders. Fast, they set up welding schools inside the factory, running classes around the clock. Women, who'd never held a welding torch in their lives, were trained in weeks and put to work. Rosie the Riveter wasn't just propaganda, she was real, and she was building. The training program was intense. New workers would come in, most of them with zero manufacturing experience. And within 2 weeks they'd be welding armor plates or operating massive stamping presses. The instructors were pulled from Chrysler's existing workforce. Guys who'd been building cars for decades and now had to teach complete novices how to work with military-grade steel. The margin for error was zero. A bad weld on a car door is annoying. A bad weld on a tank hull gets people killed. So they developed systems. Color-coded diagrams showing exactly where each weld had to go. Templates and jigs that held parts in perfect alignment. Quality inspectors who walked the line constantly, checking every joint, every rivet, every bolt. If something didn't meet spec, it got pulled and redone. No exceptions. The Army had inspectors too. Officers from the Ordnance Department who lived at the factory and signed off on every tank before it could leave. The rejection rate in the early days was high, maybe 15% of tanks getting kicked back for fixes. But as workers got better, as the systems got refined, that number dropped to under 5%. The first Sherman rolled off the Detroit Tank Arsenal line in April 1942. It took about 3 days to build. That was actually pretty good. Most tank factories took a week or more. But 3 days wasn't fast enough. Not for the numbers the Army wanted. Chrysler's engineers went back to the drawing board. They studied every step of the process. Where were the bottlenecks? What took the most time? What could be streamlined? They brought in efficiency experts, people who'd spent years optimizing car production, and turned them loose on the tank line. They rearranged workstations. They built specialized tools and jigs that could hold components in place while workers assembled them. They standardized parts so that any hole could fit any turret, Any engine could drop into any engine bay. They eliminated waste. Every movement, every tool, every second was accounted for and optimized. And then they started training workers to specialize. Instead of one team building an entire hull, you had dozens of teams, each responsible for one tiny part of the process. This team welds the front glacis plate. That team installs the transmission mounts. This other team bolts on the suspension bogies. Each worker became an expert at their one specific task, able to do it faster and more accurately than anyone trying to juggle multiple jobs. It was Henry Ford's assembly line philosophy, applied to a machine 10 times more complex than a car. The engine installation was particularly tricky. The Chrysler, a 57 multibank, was a monster. 5 inline-6 engines, arranged in a star pattern, around a common crankshaft. It weighed over 1,000 pounds and had to be lowered into the engine bay from above, using overhead cranes. The timing had to be perfect. Too fast and you'd damage the engine mounts. Too slow and you'd hold up the entire line. They developed a system where the engine would be pre-mounted on a cradle, with all the accessories already attached. Fuel lines, electrical connections, cooling hoses. The crane would lower the entire assembly into place. Workers would bolt it down in about 10 minutes, and the tank would move to the next station. What used to take hours now took less than 15 minutes. The tracks were another challenge. Sherman tracks weren't rubber like modern tank tracks. They were steel, held together with pins that had to be driven in with slip. Each track had 79 links, and installing them required workers to manually thread the track around the drive sprocket, road wheels, and idler wheel, then connect the ends. It was backbreaking work, so they built jigs. A track would be laid out on a table, pre-assembled and connected, then lifted as one piece by a crane and draped over the tank's running gear. Workers just had to make the final connection and tension it. What used to take a team of 4 guys half a day now took 2 guys 20 minutes. Drop a comment if anyone in your family worked in the war factories. My grandfather welded Liberty ship hulls in Portland. These people don't get enough credit. By mid-1942, they had the production time down to 2 days. By the end of the year, it was 1 day. And then they kept going. They kept refining, kept cutting seconds here and minutes there. They installed more cranes so components could be lifted into place faster. They built jigs that aligned parts automatically, eliminating the need for manual measuring. They set up parallel assembly lines so that if one line hit a snag, the others kept moving. By early 1943, the Detroit tank arsenal was producing a Sherman every 90 minutes. 1 tank, 30 tons of steel, armor, and firepower. Every hour and a half. It was insane. It was impossible. It was happening. Let's talk about what that actually looked like on the factory floor. Imagine you're standing in the Detroit tank arsenal in the summer of 1943. It's loud. Not just loud, but deafening. The sound of metal being stamped, cut, welded, riveted, all of it echoing off the high ceiling and concrete floors. The smell hits you next. Hot metal, cutting oil, welding fumes, sweat. The building is massive, but it's packed with machinery and people. So it's hot, even with the giant fans running constantly. And everything is moving. Overhead cranes swinging components through the air. Forklifts, zipping between stations. Workers in coveralls and safety goggles, moving with purpose. Every motion practiced and precise. The production line is arranged in a rough U-shape. Raw materials come in at one end. Finished tanks roll out at the other. But it's not a single line. It's dozens of lines all feeding into each other. Over here, they're stamping armor plates from flat steel sheets. The press comes down with a bang that you feel in your chest, and out pops a curved section of hull armor. It gets loaded onto a cart, wheeled over to the welding station, where a woman in a heavy leather apron and face shield tacks it into place. Her torch hisses, sparks shower down, and in 30 seconds, the plate is secure. Next station, another welder makes the permanent seam. Quality inspector checks it with a gauge, stamps it approved, and it moves on. Meanwhile, over on the turret line, they're assembling gun mounts. The 75mm gun itself comes from a different factory, already finished and tested. Here, they're building the cradle that holds it, the traverse mechanism that rotates it, the elevation gear that raises and lowers it. Each component has been machined to exact specifications at another station. And now they're being bolted together like pieces of a giant, deadly puzzle. The turret basket, the part where the crew stands, gets welded to the turret ring. The periscopes get installed. The ready ammunition racks get bolted to the walls. Every step is planned. Every tool is where it needs to be. The hull assembly is the most complex part. It starts with the lower hull, the bathtub-shaped base that everything else bolts to. Workers install the transmission up front, a massive gearbox that weighs several hundred pounds and has to be precisely aligned with the drive shafts. Then comes the differential, the final drives, all the mechanical guts that transfer power from the engine to the tracks. Next, the suspension. Sherman uses a vertical volute spring suspension, or VVSS, a fancy name for what's basically a coil spring and shock absorber setup mounted to bogies. The wheeled assemblies that the tracks run on. Each side has 6 bogies, and each bogie has to be torqued to exact specs. Too loose and it'll rattle apart. Too tight and it'll bind up. The side armor plates get welded on next. These are angled slightly to provide some deflection. Not much, but every little bit helps. The sponsons, the bulges on each side that house ammunition and provide working space for the crew, are bolted and welded into place. Then the front and rear armor plates. The front glacis, the sloped armor that faces the enemy, is especially thick. About 2 inches of cast steel on early models, later switched to welded plates. Workers use magnetic clamps to hold it in position, while welders seal it. Inspectors check every inch of every weld with dye penetrant, a liquid that seeps into cracks and shows up under UV light. Any crack, any flaw, and the whole plate gets cut off and replaced. While the hull is coming together, the engine is being prepped on a separate line. The Chrysler A57 multibank is already assembled when it arrives from the engine plant. But it still needs accessories. The radiator gets bolted on, the fuel pump, the generator, the starter, all the hoses and wiring. It's mounted on a steel cradle that'll let the crane lift it as one unit. When the hull reaches the engine station, the crane swings over, picks up the engine assembly, and lowers it into the engine bay. Workers guide it into place, bolt down the engine mounts, connect the drive shaft to the transmission, hook up all the fuel lines and electrical connections. The whole process takes about 12 minutes, if everything goes smoothly. The turret comes over from its line, already complete with the gun mounted and all the internal equipment installed. Another crane lifts it, swings it over to the hull, and lowers it onto the turret ring. The ring is a massive ball-bearing race that lets the turret rotate. It has to be perfectly aligned or the turret will bind. Workers bolt the turret down, test the traverse by hand cranking it all the way around. Check for any sticking or grinding, make adjustments if needed. Once it's smooth, they connect the hydraulic traverse motor and test it under power. The tracks go on last. By this point, the Sherman is sitting on temporary supports with its road wheels off the ground. Workers drape the pre-assembled track sections over the wheels, connect the ends with the master pin, and tension them with adjustment idlers at the rear. The tank gets lowered onto the tracks, and for the first time, it's sitting under its own weight. Suspension compresses. Everything settles. Workers make final adjustments to track tension. The tank gets rolled to the next station for final assembly. Hatches get installed and tested to make sure they open and close smoothly. Vision ports and periscopes get mounted. The machine guns get installed. 1 bow mounted in the hull, 1 coaxial in the turret next to the main gun, 1 pintle mounted on the turret roof for anti-aircraft. Radios get wired in and tested. The intercom system, which lets the crew communicate over the roar of the engine, gets installed and tested. Every switch, every lever, every instrument in the driver's and commander's positions gets checked. Then comes the test drive. A driver from the factory, usually a former tank mechanic from the army, brought in as a civilian contractor, climbs into the driver's seat, fires up the engine, and drives the tank through a short course inside the factory. Accelerate, brake, turn, reverse, shift through all the gears. They're listening for any unusual noises, feeling for vibrations or binding in the controls. If something's off, it goes back for adjustments. If everything checks out, the tank moves to the final inspection station. Here, an Army ordnance officer does a complete walk around. He checks every weld, every bolt, every system. He climbs inside and inspects the crew compartment. He has a checklist that's pages long, and every item has to be signed off. The gun has to traverse smoothly. The sights have to be aligned. The radios have to work. The engine has to start on the first try. The tank has to shift smoothly through all 5 forward gears. The brakes have to stop it within a specified distance. Anything fails, anything at all, and the tank gets rejected and sent back for fixes. But if it passes, the ordnance officer signs the acceptance form, and the tank is officially U.S. Army property. It gets driven off the production line to a staging area outside the factory, where it'll be loaded onto a rail car and shipped to a port for transport overseas. From the moment the first steel plate was stamped to the moment the finished tank rolls out the door, 90 minutes have passed, and behind it, another Sherman is already taking shape. Let's put that in perspective. In 1943, Germany produced about 5,800 Panzer IVs, their main medium tank. That's across their entire industrial base, across multiple factories. The Detroit tank arsenal alone produced over 8,000 Shermans that year. One factory, and there were 10 other factories building Shermans too. Fisher Body, a General Motors subsidiary, ran a plant in Grand Blanc, Michigan that produced Shermans almost as fast as Detroit tank arsenal. They specialized in the M4A2 variant, which used a diesel engine instead of the Chrysler model. Different power plant, same basic hull and turret, same assembly line principles. Fisher Body built over 11,000 Shermans during the war. Ford ran a plant in Michigan too, though they were slower to ramp up because Henry Ford was initially resistant to building war materials. Once they got going, though, they churned out over 1,700 Shermans, mostly M4A3 variants with Ford GAA engines. Pacific Car and Foundry in Washington State built over 900 Sherman. Lima Locomotive Works in Ohio built over 1,700. Press Steel Car Company in Pennsylvania built over 8,000. Baldwin Locomotive Works, another train manufacturer, built over 1,200. The numbers just keep going. By the end of the war, the United States had produced 49,234 Sherman tanks. 49,000. That's more than the total number of tanks and self-propelled guns Germany produced during the entire war. It's almost as many as the Soviet Union produced, and they had the advantage of slave labor and zero safety regulations. But raw numbers only tell part of the story. The real genius of the Sherman wasn't just that it was easy to build, it was that it was easy to modify. The basic hull and turret design stayed the same throughout the war, but the internals were constantly being upgraded. Need more armor? Weld on applique plates or switch to a thicker casting. Need a better gun? Swap in a 76mm instead of a 75mm. Need to fight in the Pacific where Japanese bunkers are dug into hillsides. Mount a flamethrower instead of the bow machine gun and call it a Zippo. Need to clear minefields. Bolt a plow or chain flail to the front. The British were masters of Sherman modification. They took standard M4 South and turned them into specialized vehicles for every role imaginable. The Sherman Crab had a chain flail that detonated mines. The Sherman Firefly had a British 17-pounder gun that could actually threaten German heavy tanks. The Sherman DD, for duplex drive, had a collapsible canvas screen and propellers that let it swim to shore on DID, before dropping the screen and fighting as a normal tank. The British even experimented with the Sherman with a flamethrower in the turret instead of the main gun, though that variant never saw much use because it was, unsurprisingly, a death trap. The Americans did their own modifications. The M4A3E2, nicknamed the Jumbo, had extra armor welded all over the hull and turret, bringing the weight up to 38 tons and making it nearly immune to most German anti-tank weapons. Only about 250 Jumbos were built, but they were used as lead tanks in assaults where regular Shermans would get shredded. The M4A3E8, the Easy 8, had a new suspension system, wider tracks, and a high-velocity 76mm gun that made it competitive with late-war German tanks. And then there were the improvised field modifications. Tank crews learned fast that the standard Sherman had some serious weaknesses, and they didn't wait for the factory to fix them. Armor was the big one. The Sherman's frontal armor was decent, about 2 inches on the glacis, and 3 on the turret front, but the sides were thin, less than an inch in places. A Panzerfaust, the German handheld anti-tank rocket, could punch through the side armor like tissue paper, so crews started welding on extra steel, spare track links, plates scavenged from destroyed German tanks, sandbags, concrete, anything to add a few more inches of protection. The army brass didn't like this. Field modifications weren't tested, weren't approved, and often added weight that stressed the suspension and drivetrain. But the crews kept doing it anyway, because it worked. A Sherman with improvised armor was slower and harder to maneuver, but it was also harder to kill, and that's all that mattered. Tankers also learned to compensate for the Sherman's biggest weakness, the gun. The standard 75mm gun was great against infantry and light armor, but it struggled against the front armor of Panthers and Tigers. So American tank commanders developed tactics. Don't engage heavy German tanks head-on. Flank them. Use your superior speed and maneuverability to get around to the side or rear, where their armor is thinner. Work in groups. One tank draws fire, while others move to flanking positions. Use terrain for cover. Use smoke to obscure your movements. The Sherman wasn't invincible, but it was survivable if you were smart about how you fought. And here's the thing that gets lost in a lot of discussions about the Sherman. It wasn't designed to fight tigers and panthers. Those tanks didn't exist when the Sherman was being designed in 1941. The Sherman was built to fight Panzer IIs and IVs, and against those, it was more than competitive. The 75mm gun could knock out a Panzer III or early Panzer IV from 1,000 yards. The armor could stop most German tank guns at range. The speed and reliability meant Shermans could outmaneuver German tanks and get to advantageous positions first. The problem was that by 1944, the Germans had upgraded. They brought in Tigers with 88mm guns that could kill a Sherman from 2 miles away. They brought in Panthers with sloped armor and high-velocity 75mm guns. The Sherman, designed in 1941, was suddenly facing tanks, designed in 1943 and 1944. It's not surprising, it struggled. The amazing part is that it still won, because for every Tiger or Panther, there were 5 Shermans. And those 5 Shermans were backed by artillery, air support, and an industrial base that could replace losses overnight. The Germans couldn't replace their losses. Every Tiger they lost was gone forever. Every Panther that broke down was abandoned because they didn't have spare parts or recovery vehicles to bring it back. The Shermans kept coming. There's a famous story from the Battle of the Bulge, Germany's last major offensive in December 1944. A small group of American tanks and tank destroyers held the town of St. Vith against repeated German attacks. They were outnumbered and outgunned, facing Tigers, Panthers, and assault guns. They lost tanks, but every time a Sherman got knocked out, another one would roll up from the rear to replace it. The Germans would knock out 3, 4, 5 Shermans, and there'd still be more. The American defenders held St. Vith for days, buying time for reinforcements to arrive and blunting the German advance. The Germans called it a small Stalingrad. They threw everything they had at that town and couldn't take it, because the Americans had an endless supply of tanks and the will to keep fighting. That's the real story of the Sherman. Not that it was the best tank, but that there were always more of them. The production line back in Detroit, and Grand Blanc, and all the other factories, never stopped. Day and night, around the clock, Shermans rolled off the assembly lines. Ships carried them across the Atlantic. Trains carried them across Europe. And everywhere they went, they tipped the balance. Let's talk about the human cost of this production miracle. Building tanks at this pace required a massive workforce. And most of that workforce was made up of people who'd never worked in a factory before the war. Women, primarily. Before the war, women in manufacturing was rare. Cultural norms said women belonged in the home, not on the factory floor. The war changed that overnight. Men were being drafted by the millions, and someone had to fill their jobs. So women did. By 1943, women made up over 30% of the workforce at the Detroit tank arsenal. They worked as welders, machinists, assemblers, inspectors, crane operators, forklift drivers. Every job that wasn't explicitly prohibited by safety regulations, and they were good at it. Studies done during the war showed that women were often more precise and careful than men in tasks requiring fine motor control, like welding thin joints or aligning delicate components. The rejection rate on work done by women was actually lower than the rate for men, but it wasn't easy. The work was physically demanding, often dangerous, and the hours were brutal. Factories ran 3 shifts, 24 hours a day, 7 days a week. Workers might be assigned to the night shift one week, the day shift the next, never getting into a rhythm. Overtime was mandatory. 60-hour weeks were common, sometimes 70 or 80. The pay was decent, better than most women could make in traditional women's jobs, like secretarial work or teaching. But it was still less than what men made for the same work. And the factories were dangerous. Heavy machinery, moving cranes, molten metal, high-voltage electricity, all in a crowded space with tired workers. Accidents happened. Fingers got crushed in presses. Workers got burned by welding torches or splashed with molten steel. People fell from catwalks or got hit by moving equipment. The safety protocols of the time were nowhere near modern standards. Hard hats weren't mandatory. Safety glasses were optional. Hearing protection didn't exist. Workers just dealt with the noise and the hazards as part of the job. There's a particular kind of injury that was common among welders called arc eye, or welder's flash. It happens when you look at a welding arc without proper eye protection. The ultraviolet light from the arc burns your corneas, like a sunburn but on your eyeballs. It's incredibly painful. Feels like having sand rubbed in your eyes, and it doesn't show up until hours after the exposure. Women working the night shift would finish their shift, go home, try to sleep, and wake up in agony. The treatment was basically to stay in a dark room, with cold compresses on your eyes, and wait for it to heal. which took a couple of days. Then you'd go back to work and try not to make the same mistake again. Despite the hardships, many women who worked in the war factories look back on it as the best time of their lives. For the first time, they had economic independence. They were doing work that mattered, building machines that were literally saving the world. They had camaraderie with their coworkers, a sense of purpose and pride that many had never experienced before, and they proved, to themselves and to the world, that they could do anything men could do. After the war, most of these women were pushed out of the factories. The men came home, and society expected women to return to being housewives. Many did, but many didn't. The genie was out of the bottle. Women had tasted independence and skilled labor, and that experience would fuel the women's rights movements of the 1950s and beyond. The Sherman's legacy extends far beyond World War II. After the war, thousands of surplus Shermans were sold or given to Allied nations. Israel used Shermans in the 1948 Arab-Israeli War and continued using upgraded versions into the 1960s. The Israelis were masters of modification, mounting French and British guns on Sherman hulls, upgrading the engines, and turning them into viable tanks decades after they were built. Some Israeli Shermans saw combat in the Six-Day War in 1967. More than 20 years after the last one rolled off a production line, Argentina, Chile, and other South American countries used Shermans. Into the 1970s, Pakistan and India both operated Shermans. The tank showed up in Korea, where it fought against Soviet T-34s, a matchup that was much more even than Sherman versus Tiger. In Korea, Shermans proved they could still hold their own against contemporary designs, especially in the mountainous terrain where maneuverability mattered more than raw firepower. The basic design principles that made the Sherman successful, standardization, ease of production, reliability, became the foundation for all future American tank development. The M26 Pershing, the M46 Patton, the M48, the M60, all of them owe something to the lessons learned building Shermans. Even the modern M1 Abrams, as advanced as it is, incorporates ideas about maintainability and standardization that trace back to the Sherman. The Detroit tank arsenal itself continued operating after the war. They built M26 Pershings, then M46 Pattons, then M47s and M48s. During the Cold War, they produced thousands of M60 tanks. The building is still there, still making military vehicles, now operated by General Dynamics Land Systems. If you drive past it on I-94, you can see tanks sitting in the parking lot, waiting to be shipped out. The production line that started in 1940 never really stopped. Let's circle back to that number. 90 minutes, that's what it came down to. 90 minutes to turn raw steel into a weapon capable of changing the course of history. That achievement represents something bigger than just engineering. It represents a shift in how wars were fought. For all of human history, wars were won by whoever had the best soldiers, the best generals, the best tactics. World War II changed that. It became a war of production, of logistics, of industrial capacity. The side that could build more tanks, more planes, more ships, more bullets, faster than the enemy could destroy them, that side won. Germany had better tanks. The Tiger was superior to the Sherman in almost every measurable way. Better armor, better gun, better optics. But Germany couldn't build enough of them. Each Tiger took months to produce and required skilled labor that Germany was running out of. The Soviets had better tanks too. The T-34 was arguably the best all-around tank of the war, and the IS-2 heavy tank could go toe-to-toe with anything the Germans had. But Soviet tanks were unreliable, poorly built, and crews were often sent into combat with minimal training because the Soviets prioritized quantity over everything else, including the lives of their own soldiers. The Americans found the balance. The Sherman was good enough to win fights against most enemies, reliable enough to keep running, and simple enough to produce in numbers that overwhelmed the opposition. It wasn't perfect, but it was the right tool for the job. There's a lesson there that extends beyond tanks and wars. Sometimes, good enough and plentiful beats perfect and rare. Sometimes, the ability to iterate and improve quickly is more valuable than getting it perfect the first time. Sometimes, the answer isn't to build one amazing thing. It's to build 1,000 decent things and keep making them better. The engineers who designed the Sherman understood that. So did the workers who built them. They knew they weren't creating a masterpiece of engineering. They were creating a tool, a weapon, a machine that could be produced faster than the enemy could destroy them. And in doing so, they created something more important than the best tank in the war. They created the tank that won the war. Picture this. It's May 1945. The war in Europe is over. Germany has surrendered. In a factory in Detroit, the production line finally stops. For the first time in 3 years, the assembly line sits silent. No more metal screaming, no more sparks flying, no more tanks rolling off every 90 minutes. The workers, many of them exhausted, stand around in a kind of daze. They've been doing this for so long, working at this insane pace, that the sudden silence is almost jarring. Someone starts clapping, then someone else, then everyone. They're applauding themselves, and they've earned it. These people, most of them ordinary civilians who'd never built anything more complicated than a car before the war, had just accomplished something extraordinary. They'd built an army, 49,000 tanks, hundreds of thousands of engines, transmissions, tracks, guns, radios, all the components that made those tanks work. They'd done it under pressure, under deadlines, with lives hanging in the balance, and they'd succeeded. Outside the factory, a Sherman sits in the packing lot. It's one of the last ones, fresh off the line. The paint is still wet. The engine has maybe 10 hours on it. It'll never see combat. The war's over. This tank will probably end up in storage somewhere, then sold as surplus, maybe shipped to some allied nation, maybe cut up for scrap. But for right now, it sits there, a monument to what American industry could accomplish when pushed to its limits. 90 minutes, from raw steel to finished tank. 90 minutes to build a machine that would help liberate Europe, defeat fascism, and reshape the world. That's the legacy of the Sherman. That's the legacy of the Detroit tank arsenal. That's the legacy of the engineers, the workers, the welders, the crane operators, the inspectors, everyone who played a part in this production miracle. They proved that when America decides to build something, really commits to it, there's no force on earth that can match its industrial might. The Sherman wasn't just a tank. It was a statement. We can build anything, and we can build it faster than you can imagine. If you want to see how the rest of American industry stepped up during the war, hit that subscribe button, because the Sherman was just the beginning.